So you wanted the indifference curves pointing the other direction? So you really want kind of clarification on why we draw the thing we hate or the thing we like? Is that what I'm hearing? Okay. So, hey! You guys notice anything different?
Oh, you got 2 boards.
I got my boards. All of a sudden, I was like starting to go here like, okay, I gotta think, and then I'm like, well, wait a second. Awesome. Gosh, you don't know how much that makes me happy. I just went down. Remember when I said that? After class that day, I went down and talked to Dennis Tyner, and I had mentioned it, I think, before briefly, but sweet. Sweet.
Problem is something that she doesn't really care about. Something
Yeah,
she doesn't like.
The hate and the love or whatever is part B, and that's broccoli and carrots.
Yes, yes, and there's a distinction there that we can talk through too. So I think I'll still start here. So let's see. Let's look at the hip hop one. Which one did we put on the vertical?
Heavy metal.
Heavy metal. So we've got heavy metal and hip hop. And the indifference curves ended up being like this, correct? And you're wondering why they wouldn't be like this, right? Okay, so one of it is thinking about the indifference curves. So U1 and U2, this is a higher level of utility for this person, right? So no matter how much more heavy metal I get, I don't get any happier. The only way I get happier is by getting more hip hop, given these 2 goods. Does that help, just thinking about it that way? So if I move from point A to B, I don't have any more hip hop, but I've got more heavy metal, and I'm not happier one bit. So it's pointing to the thing you love as just kind of my mental way of remembering which way they go. If you're struggling, if you want a quick kind of memorization, I kind of think of arrows pointing towards the thing you love, not the thing you don't like or you hate.
If you put it horizontal, then if you have like 2 hip hop or 10 hip hop, you have like the same utility, right? On the same thing.
If you say that one more time.
If the indifference curve was horizontal instead of vertical,
Yeah.
and you had 2 hip hop or 10, would be like the same indifference.
Okay. Yes. Yeah, so let me.
Which means you would rather have heavy metal if it was horizontal.
So if you have 2 units of heavy metal, you're wondering if there's an interpretation of that? Is there an interpretation that makes it look like that?
I don't know. I think that's just how I thought about it. Is that the right way to think about it?
That's not the right way to think about it. That's why I wanted to make sure. So this is telling the opposite. So then tell the story again. What's the implication of something like this? It says that I'm indifferent between point A and B, which isn't true.
That's what she said. That's why I figured out.
Oh, that's how you figured out that it goes the other way.
Yes.
Okay. That's fine. Yep, as long as they don't look. So you did a kind of a counter argument. Like, I know it doesn't look like this because I'm happier if I get more hip hop.
Yeah.
Okay. That's fine. Yep. And then erase it quickly so that I don't see it. Yeah, so they wouldn't look like that. It might be easier on some of these to, instead of thinking of lines, think of points. So just arbitrarily pick a point out in space at 2 and 3. If you pick a point rather than drawing the line, now tell yourself the story. If I have more hip hop, am I better off or not? Or if I have more heavy metal, am I better off or not? And so I can't go that direction, and so you end up being able to draw these lines. I'm not any happier with more hip hop, and then you kind of connect the dots. So whatever works. Yes?
On brothers' complements, if it's a 2-to-1 ratio, I was confused at why the corner was still.
Okay, yep. Let me come back to that one. I want to, since we're kind of on the issue here of this, we had the broccoli carrot thing that gave us a different look with an indifference curve that looked like this. Right? So that was a bad instead of a good. So does anybody have any questions there?
I don't know how to ask the question, but I just had a bunch of questions.
Okay.
I didn't really understand.
So, the textbook does a pretty good job on looking at, let's see, what was their example? Commute. It was a commute, didn't like commuting. So I wanna maybe add a little bit to this thought, because I had another comment that I think would be relevant. So if you, while we're waiting for this thing to warm up, pollution is a bad, right? The more of it we get, the unhappier we are. And so a little trick that you can do when you have bad things and you're trying to think of trade-offs is to turn it into a good thing. And so instead of thinking of pollution, let's think of clean air. So now as we go this way, I like clean air, I'm getting rid of pollution. Right? So we can sometimes flip the logic, and that's where that indifference curve then comes from, is the avoidance or absence of the bad gives us additional utility. And if you do that, you can draw the regular indifference curves that we're accustomed to. So on this problem, this way you can kind of just look back to it. Power. Take a little warm-up time. On this problem, we have a person thinking about the number of friends living in a building versus the commute time to get to work. So there's a trade-off there. I'm happier when I have lots of friends living in my apartment building, but all my friends are living further from work. I could live closer to work, and so I have a longer commute time, which is a bad, being weighed against living with my friends. So this is one problem I have with hardcover here. Okay, so I suppose I could have drawn this just as easy, but now you can reference back in your book. So the indifference curves go U1, U2, U3. So we're getting happier as we move this way. And as the commute gets longer, I'm getting more friends, so I'm just as happy. So one way to think about it is holding the number of friends, or holding the commute time constant, I'm happier at point C. Right? So you see that? So A to C, I'm on a higher indifference curve, so I'm happier. If I was able to hold commute time constant, I'm happier with more friends. That being said then, there's a commute time that I could trade that would leave me indifferent. Taking on that bad, there's a commute time that, as long as I keep my level of friends constant, would put me back on this indifference curve. So there's some sort of trade-off going on there where you're willing to take on a bad because there's a good that you're also getting. The thing that the textbook doesn't get into that might be helpful is thinking about it being a joint product. So this is a little more advanced topic that we might get into later in public goods, but where I live, the consumption of my apartment is actually the joint product of multiple things, right? You got the commute time, the number of friends, square footage of the apartment, number of bedrooms, bathrooms. I mean, there's a whole bunch of things. It's a joint product that I'm actually consuming. Oftentimes we simplify that down to one single good named apartment or whatever. But in reality, there's some sort of technology of that's putting together the bundle that we call the apartment. And what this highlights is that the number of friends can outweigh, that benefit can outweigh the bad that you're taking on with the commute. And so that's where we get the shape of that indifference curve, because the positive effect is outweighing the negative effect that you're taking on for a net benefit. Right? So that's what's giving this kind of weird thing. And this is certainly getting deeper into the theory of the consumer. All of that stuff, though, is helpful when we start to become a business, thinking about how to price our goods and bundle things together. These type of behavior things you got to be thinking of. So it's helpful to have this foundation in consumer theory to draw on.
And for this example, the bad was on the x-axis and the good was on the y-axis. And then in the problem we did for our homework, they were switched, and so the curve like did that way. Is that just always like going to be that way?
So there's even diminishing returns to friends. The fifth friend is great. Well, what if I added the sixth friend? How much more utility do you get from the sixth friend, the seventh friend, the eighth friend? So we get kind of diminishing marginal utility off of additional friends. That's where this shape comes in. The curvature here, if you think about what's happening to the marginal rate of substitution, it's getting steeper and steeper and steeper, meaning that there's diminishing marginal utility to friends being added on to the apartment. Right? So on the other problem, the bad broccoli was up here and the curvature was concave to the origin rather than convex. So it's always kind of bowed towards the bad is what it ends up being. Slightly bowed is what we'd expect. There could be a linear preference technology where you're trading off. Again, that comes down to consumer preferences. But general consumer preferences would give it this shape. Now, let me come back to the topic of switching is now. So if we turn the bad into a good of saved commute time, it's kind of like our air pollution. Instead of pollution, we're going to look at clean air. Instead of commute time, the longer it gets, the worse. I'm going to have saved commute time, flipping it to a good. I'd rather not have as much commute time. Saved commute time. Then that indifference map flips to what we're used to. Convex indifference curves that look like that. And then you get the normal trade-offs and all the properties that we had before. Okay, Chelsea. Compliments, 2-to-1. Why don't you try to characterize the issue that you were having?
I just saw it I know the perfect complement was like corner, and I don't know, we had a couple different ones for the 1-to-1 and 2-to-1 ratio. But
Yep.
On D, it was cufflinks and dress shirts, but they still had the corner at 1-to-1. And I was talking to Kate last night, and she showed me how even if it was a 2-to-1, they'd still be on that indifference curve, so maybe it doesn't matter. But I just naturally wanted to corner at 2-to-1, and I didn't know if that was wrong.
You were right wanting to put it there, but I think your interpretation of the answer key was wrong. I don't think they were they didn't show a graph for that one. Was the way I kind of read it?
They did on
This
D.
is,
They
yeah.
did on 4.
On the very first one on D, they did. And
Okay.
I think he's thinking about shampoo and conditioner right now.
So part
Part D on number 4.
so number 4. Oh, this was number 4.
it's on it was on 15 too.
Yeah.
Oh.
But
Okay, I was thinking about 15.
Yeah, it's
On
on
15 part D, it says, how would your answer change to Mitzi if she uses 2 squirts of shampoo to 1 squirt of hair conditioner each time she washed? I don't think part D, they're just asking how it changes. They didn't expect a graph, so I didn't think
They just
that
showed
tied
graph.
back.
They just-
Yeah, but the graph they showed was related to part C,
Okay.
I think is what
Okay.
happened. That's what I was. That's how I interpreted that. So they had this one right here.
Oh, so that's tied to C.
See, this graph is tied to C. So letter C comes here, and they say the graph, and then part D. D doesn't correlate to the graph.
Gotcha. Okay.
So I think you're right on that 2-to-1. I'm not sure. You said number 4, part
Yeah.
D. Dress shirts and cufflinks are perfect complements. So they show the 1-to-1 graph, and then you're saying,
But it's asking about 2 to 1.
yeah, then that might be.
But like Kate was talking about last night, and we looked at how like if it was 2 to 1, it's still on that same like indifference. Kate showed me something that I saw like.
Okay, well let me.
By 1-to-2 proportions, is it just meaning?
No, you're right. That graph is wrong. If that graph correlates to that, it's wrong.
Because
So here's basically what they have in the text, right? Now this is where the magic of golf clubs is going to come in handy, folks. So U1 and U2. And what do we got down here? Dress shirts and cufflinks. Okay. So we're okay with this picture. So if we have some budget constraint here, it doesn't matter what the prices are potentially if they rotate through enough. I think one of your problems had prices, both prices changed. One went down, one went up, and it left you at the same solution, right? So there's lots of, when we talk about the margin rate of substitution, the slope of the indifference curve at this point, we don't have a real friendly first derivative there, right? It's actually a slope that ranges between here and here. There's an infinite number of slopes that represent the slope of the indifference curve at 1, 1. So there's lots of possibilities here on the price ratio. There's an infinite number of price ratios that would get us to that solution. Now, if you consume the good in the 2-to-1 ratio,
Wouldn't there be kind of like it would come down on the 1 and then it would like diagonally go across 10? Is that where I'm kind of thinking of?
I'm not sure what you're thinking of, but if I,
Sorry, just
well, if I put a price ratio of whatever this is, and I drop the price of dress shirts, I can and keep cufflinks the same. The only way that I'm going to buy more is if the price was good enough to get me up to that incremental amount. Like that price decrease does nothing for me. If I have to consume them in these incremental units, assuming I can't have 1.6 cufflinks, right? So the only way is that this price ratio would have to change to there. The price of dress shirts would have to fall enough for me to now consume 2 and 2.
This doesn't make sense to me because if you have one shirt, you're going to need to start out with 2 cufflinks. This is assuming a 1.
This is 1-to-1. Yep, I'm starting with 1-to-1.
Okay.
All right, and we don't know what the utility function is. We don't know maybe how many other inventory of shirts this person has, possibly, right? We're kind of ignoring that type of thing. We're just kind of solving the problem given its potential non-real world application. So be careful of that sometimes too. I think this book does an awesome job of keeping things pretty real world. I mean, I could show you guys 5 other intermediate textbooks, and it's all X's and Y's, and it's no fun stuff like we're doing here. So the 2-to-1 thing then, if this consumer, this is like a different consumer, or the consumer changed their preferences, it's a completely different story, right? So we're talking about maybe another person, and that person has this 2-to-1 preference. Their indifference curves look like this, maybe. Let's just call this U100, just to be crazy. 3, 4, and now we jump out to U200. That's that person's 2-to-1 preferences if they always consume them in this 2-to-1 ratio. And so this is the way the picture should have looked for 4D. Right. I think they screwed it up.
They just showed a 1-to-1.
Yeah, they showed a 1-to-1, and didn't they explicitly say 2-to-1 in the problem?
Yeah.
Yeah.
The answer they gave for the last part of 15, I didn't really understand it because I felt like it didn't really answer the question that they like asked.
Okay, we'll review that. Let me stick with this one for a second. So we still get the same implications with the the solution being here, depending on what the prices are. So is everybody comfortable with this? I mean, that's the way it looks. If it's a fixed, it's called a fixed proportion preferences of you're always consuming in these fixed proportions. Okay, which are unusual cases, perfect complements. So 15, you want to go over the answer for 15D.
Just to finish up something real quick.
Yep, go ahead.
The cufflinks and dress shirts one, the example still is completely wrong. That's at least the answer. If we're doing 1-to-2 proportion, it still shows as the answer.
That's what we're saying is wrong.
Okay.
Yep. I think they just, this is what that answer should have looked like.
Yeah.
Yep. So that's the wrong one. I'm going to try to keep some notes for feedback back to these guys on what's. Let's see, that was 4 cufflinks. This one's wrong. They are perfect complements, but you said to do 2-to-1.
Well, it said like it was perfect complements, and it was like 1 and 2 proportions. So if the 1, it was the 1, and the 2, the 2. Is how it like said the question.
But it was 2 units of 1 to 1 unit of the other.
No.
No?
It's just the 1, the proportion at the 1, and it's, I don't know. You can read it, but that's what I got. Like it didn't.
Who's got their book?
Yep.
It says Michael only likes dress shirts and cufflinks in 1-to-2 proportions.
1 to 2 proportions. I would read 1 unit to 2 unit. That's not perfectly clear, but that's how I would read that. If it's 1-to-1, then it would be what they've got drawn. So 1-to-2 would be 2 units for every one. We can talk more, Brinson, after class if you want. This one then, right? Okay, if Mitzi likes to use shampoo and conditioner 2-to-1, then under the original prices of consisting of S = 2 and C = 1 would have cost 10. With the change in prices, the same bundle would cost 8. Mitzi would be able to consume more under the new prices. Okay. So what about that don't you get?
Well, like it asked, it was like asking like what could Mitzi like, what would be like her optimal selection if the price was like.
So it's not that picture above. It's what is it? 2. Which one's 2? Shampoo at 2. So 2 squirts of shampoo, 1 squirt of conditioner.
It actually changes to the concept of what we were doing before, where it's like rather than going,
It says, and what it says, the C says, what is likely to happen from Mitzi's optimal bundle, and then D says, how would your answer change?
Right. And so we had prices involved. Prices were at what?
well, it said
Prices
use your
are
own
shampoo's $2.
Oh, yeah.
Conditioner's $4.
Shampoo is 2 to 4, so we have a slope of 2 here, right? So if we had a budget line, conditioner's twice as expensive as shampoo. Is that right? So we'd have a budget line. Oops, that's right. My blue is actually green now. I put it in a different color. We'd have a budget line that looked like that. That's one of them. So depending on how much income we have, how much spending would be going on this arbitrary budget line that I just did. So what's what's my income related to this? How'd you get that? 4 times. So we have 4 units times, how much is it per bottle? 4 per bottle, so $16 worth of spending, right? So we got $16 worth of spending at that
Yeah.
conditioner.
It needs to be 2 conditioner portions.
Oh, yeah.
Well,
Conditioner was the more expensive thing.
not
Yes.
here.
There we go. So at this consumption bundle, they'd be spending $16 at 2 and 1. Is that right?
So they'd be spending
And now they'd be spending 8,
yes.
right? So what happened to the budget line when the prices changed? Because the prices changed in this one?
It changed from B to C.
The ratio changed.
The ratio changed. So we had the 1-to-1 before. And
Well, there was between B and C, the prices flip-flopped, and between C and D, the ratio of what you're actually consuming changed.
okay.
So originally, conditioner cost less than shampoo, and then that
So this picture's right how we started. Is this part C, or did we even start in a different spot?
That's correct.
yeah.
Oh, here we go. So here is our initial starting. Is that what you're saying? So we were consuming 2 and 2. Then price of one got cheaper.
Yeah, but the other one, like, it was from
Oh,
4
they
to both
2. Changed.
It was from 4 to 2.
That's
to
what
2
kept
to
us
4.
at that same consumption bundle.
Exactly.
Okay, that's right. I forgot about that
The
part.
ratio went from 1/2 to 2. Or
Okay.
2 to 1/2.
So everybody clear on this point? I forgot that they both changed. That's what I think we had one changing when we were looking at it before. So both prices changed, and we stayed at the same consumption bundle with the level of spending staying the same at 2 and 2 here. So that was our $10. Or
They used, well, you could take whatever income you wanted.
okay. But at this particular consumption bundle, if there's 2 units of shampoo priced at, what was the price?
Changes to $2.
At 2. So 2 times 2 is 4, plus 2 times 4 is 8. So we got $12 worth of spending going on, right? So kind of remember that you can go back and forth on your spending level. And then we have the switch from a 2-to-1 ratio. So we kind of want to think about transforming this now to the 2-to-1. Our income hasn't changed, presumably, nor has the price levels. Our preferences changed to this 2 squirts to 1.
So you leave your budget line the same and just look at your
Yep. So your indifference map changed, your indifference curves changed, but the whole map actually changed. But remember, when we think about the map, I want to think about maybe the more 3-dimensional creature kind of can morph over time, and so maybe as you got older, you didn't care when you were 14, but now that you're 16 and you're attracted to other people, you need to do 2 squirts instead of 1. Something changed so that you're changing your indifference map. And now, on this picture, how are we consuming it? How has this morphed?
From 1 to 2.
So which one's the 2 and which one's the 1? So shampoo's 2, 1 squirt here. So the new indifference curve here would look like this. And then what if we went back 1? If I'm using 1 squirt of shampoo, what's the amount of conditioner I've at? A half. So I've ramped down. So we can kind of think about that one. So that would be kind of a picture if we were to do kind of this U1, U2, and then of course there's more following this preference ordering coming out from away from the origin. And now that we're at this 2-to-1 ratio for 1 shampoo job instead of 2 for 2, would have some money left over at this consumption bundle, which would we be operating as happy as we can be at that point? No, we're not. So there's leftover money at that point. We're operating inside the budget constraint, which is not an optimal condition for the consumer. So they kind of leave it here, and I don't know if this is part of what was throwing you, Brenson. With change in prices, the same bundle would cost 2 plus 4 equals 8. Mitzi would be able to consume more under the new prices. So how would we show that? Would be this graph right here. I'm consuming at this point, if I call this point, let's just call this point A, but I could be anywhere along the budget line, potentially. And so I can consume more of both goods. I could consume more of conditioner, more of... Now, it doesn't make me any happier in this particular case, because this is where we've got a weird... If we're allowed to buy a half a bottle of shampoo or a fraction of a conditioner, this would be the better point to be at, somewhere over here. Buying one more bottle of shampoo with my extra $2, does that help me out at all? No, not in terms of your current consumption. But if we're allowed to have, if shampoo is in thousands of bottles or something, then we could have one more bottle. Okay? Am I confusing you more than I'm helping you? Because it brings up some important points with how we do increments. This is called the discreteness problem in math. So am I forced to consume on the button, or can I have partial units in between? Is kind of what we're getting at. So this is at least addressing that. I've got money left on the table. I got $2 left. I'm currently inside here. Can I make it out to a higher difference curve?
I think right now, C and D, C even asks us a question that doesn't really affect the indifference curve more so than anything. It's just, pertaining to the budget line. So
Totally.
To bring indifference curves in, it's just confusing at this point, to me at least.
So you kind of bring up a good question. Am I happier when the price of shampoo falls? Does a change in the price of shampoo make me happier?
If you like the 2-to-1 ratio. Yeah.
So you're adding a little bit more, but
Oh, sorry.
in general, if I stick strictly to what I'm saying, does a drop in prices make me happier?
Yeah.
Depends. Because the other price went up.
So when you think happy now in intermediate class, what function comes to mind? Utility. Is price an argument in your utility function? No. The quantity of shampoo and the quantity of conditioner is an argument in your utility function. Price is a part of your budget constraint. So as Chelsea started to explain, she was adding in a little bit more level of detail. Yes, I like lower prices because it allows me to buy more stuff. It's the stuff that you get from lower prices that ultimately makes you more happier. But that's an important distinction between separating our preferences with the utility function and what the market gives to us in terms of prices and income. Cadence.
I have a question on 17B, which I kind of know the answer is. I was wondering if you could maybe
Okay.
just figuratively, but where they wanted their utilities to stay the same, and we had to solve for the income.
Okay.
Chelsea tried really hard to explain to me already, but I didn't quite get it.
Okay. So was
why are they able to plug that final utility from before back into the budget line equation?
Okay, let me get the problem out here. Chapter 4, number 17.
17B.
17B. How much income must Anthony have to maintain the same level of utility? Okay, so this is part of what I wanted to talk about today was related to that, so this is perfect. It really comes down to characterizing the consumer's problem differently in terms of minimizing expenditure subject to a given level of utility versus maximizing utility to a given level of income. Those are related but different problems. It's the dual problem. The math is, it's kind of like the mirror image of what our normal consumer maximization problem is. So the normal, if we can call it that we've been doing is to maximize utility subject to the budget. The dual problem is to minimize expenditure subject to utility constant at some fixed level u bar, a function of some arguments. So here we're making ourselves as happy as possible. So number one, I guess, graphically, the one we've been doing is to say, okay, here's your budget. Here's your budget line. That is your constraint. So this is your constraint. Make yourself as happy as possible. Find the indifference curve that leaves you as happy as possible given that budget constraint. And that gives us our optimal solution of dress shirts and hairspray, or hair cufflinks. I don't know where the hairspray came from. Number two, over here, the problem is characterized like this. Given your utility being held constant at 100, find me the minimum amount of spending you have to do to be that happy given a certain amount of prices. So your total expenditure is equal to the amount you spend on the price of dress shirts plus the quantity of, or times the quantity of dress shirts plus the price of cufflinks times the quantity of cufflinks. These are still given to us. It doesn't work having my blue be a green. These are still given to us in the marketplace, which ultimately gives you the slope of a line. So given that the slope is constant, whatever those prices are, there's a whole bunch of, there's an infinite number of expenditures. These are all supposed to be parallel. There's an infinite number of spending that you could do given that relative price ratio, the slope of the line, and we're going to spend the least amount of money possible to keep myself as happy at this level. So now the indifference curve of utility is technically, from a math standpoint, the constraint. We're doing an expenditure minimization versus a utility maximization. The constraint and the objective have flip-flopped. My objective function here is utility subject to a budget constraint. Now my objective is my expenditure, which is the amount of money I'm spending, subject to a constraint of utility being held constant. Does that help out characterizing the problem anyway? Okay. Does the rest of the problem kind of fall into place having that understanding? Maybe? Or is there anything deeper or some of the specifics with that one that you want me to?
Well, how you do that in numbers?
Okay. We went through the problem. The last problem we did on Monday was maximizing utility subject to the budget constraint, right? And we did that by thinking about the first order condition. The slopes at this point, we know that the slopes of the budget line, which is the price ratio, the price of dress shirts over the price of cufflinks, that is the relative price, is equal to the marginal utility of dress shirts over the marginal utility of cufflinks, which is the marginal rate of substitution. So this is the slope of the indifference curve, which is fixed. This is the slope of this expenditure function, which is like our income. In equilibrium, the same thing holds. We're just thinking about it differently. And so now, instead of making utility as high as possible like we did on the regular problem, we're going to make expenditure, which is like our income, as small as possible, our spending. So it all kind of comes back to this equation to solve the math out using that.
So when you have a utility, you assume that maximum utility is your quantity?
Are you in reference to this problem? So there was a utility function given to you, right?
Yeah.
So utility equals, why don't you give it to me?
The square root of LG.
Square root of what?
Is LG.
LG, okay, so it's of two arguments. So we had these raised to the half. That then, and then they gave you the optimal, they gave you the marginal utilities, right? So then you do that ratio like we did in the other problem. So you got that. You've got the prices, right? So you plug in the prices, you solve for one of them, substitute it back into the utility function now, because now you'll have one of these arguments as an argument to the other. Utility was held constant at a given level?
You had an A out of the solve for it.
Oh, you had to solve for it.
And then B, one of the prices changed, and it wanted to know what income you would need to keep the same level of utility.
Okay. All right, work through that one. Again, I think you'll start to see it now. If you've got this, you can plug stuff back into the other equations, and I'll be happy to look at it with you individually too. Okay, anything else? Yes.
Like on 4, the graphs were really general, and like we didn't have to like solve specific points for the indifference curves and stuff. Is that going to work on the test?
Yes, there could be a more general question like that about indifference curves. The other thing I wanted to talk to you about was corner solutions. What's that? I kind of wanted to just bring it up as a foreshadowing for next time. We have corner solutions that come up with the indifference curves that we were doing earlier. If your indifference map looks like this, and you want to minimize expenditure, how many are you going to buy? Well, your solution is right there. You're going to push yourself out to make yourself as happy as possible. The slope of this is not defined, right? So you're going to have trouble with the slopes. And so this is when you get into a unique situation where if you're given preferences like this, then the solution to the problem is to buy all hip hop and no heavy metal. And that's called a corner solution, just because we're forcing it to be at one of the extremes. And if you have an indifference curve that instead of being, it has some curvature to it. If you've got an indifference curve that has, instead of this steep, it's got some curvature to it, like, and maybe it even, for some reason, changes here. So there's a curvature to it, so there's some function, but the tangency line would be somewhere in some weird space. So the slope of this indifference curve is that. The budget line's here, and again, you're forced to a corner solution. Even though it's curved, you're not going to have an interior solution on that. I think this is helpful working through this because you are doing optimization problems. Chapter 5, we're going to come back, but just think about where utility is increasing, and that's how the answer would change to possibly finding the optimal solution at one of the endpoints if you have one of these extreme conditions.
So we won't be having a corner solution.
No.
Just
No. I just wanted to throw that in here for these oddball ones that you might be asked to graph. Thinking about the preferences, that's where it would go for a solution.
On the test, what's the make of it going to be? Is it going to be like all word problems that you've gotten in the book?
Probably, I'm thinking word problems like this. So I'm going to have you work through some problems. So do your homework, know them inside and out, and review them. If you want, I'll return these to you. Why don't you turn these in?
Do you have mailbox possibly?
In fact, is everybody here today? Everybody's here, right? I think I'm going to return them to you right now. I'd rather have them in your hands. Let me see. Just let me know if you didn't accomplish your homework.
What? You thirsty?
Are you guys finding it helpful to work through these problems in the way we're doing it? Okay. I mean, that's the way it always worked for me in school, too. And as you work through it, it's good to see. Oop, you're not Kate. Anybody else? So you can grab these back. You got full credit. Good job. Study hard. So I'm not going to pull any punches on you on this first test. I want to know that you can come in cold to a problem without having the luxury of that answer key. You'll probably see some problems maybe similar to what we had as a hint. So you guys could tweak some of these functions and test yourself internally. Make sure you work through. That's the type of thing I want to see you be able to do.